Alright, let's take a look at page 67 today. We're going to start our next section. Yesterday with domain and range in terms of equations, I think went really well. You guys seem to adapt good to those techniques or things to look for. This section is not necessarily related to domain and range, but we will see kind of in the near future how we can relate the two. We're just going to make sure that we cover our bases first. This section we're going to be composing functions. Not sure if you've heard that word before used in a math sense, but what's your basic understanding of composing or composition? Have you heard that word used in a different context? Like a different class or scenario? Any musicians in here? Composers? Composing a piece of music? What do you think that means? Yeah, Maddie. Say it again, sorry. You're making it or creating it, okay? In terms of, so what we're going to be doing here is we're going to be making these different values, or essentially trying to figure out what they are. Composing is when you bring multiple pieces together to kind of create something new. So in terms of a musical sense, if you think of a composition of music, you bring in trumpets or drums or brass instruments, whatever it might be, to compose a piece of music, kind of like an orchestra. Okay, so what we're going to be doing is composing functions or values here. We're going to be taking different values from different graphs and bringing them together to figure out what a specific value would be. Does that make sense? We're not just looking at one graph or one function. Notice how in this case we have three. We have three different functions, and we know some different points on those different graphs or those different function values. So we're going to use the table. Sometimes we'll be given a graph. We'll see what that kind of involves. Sometimes we'll be given an equation. But it doesn't matter what information we know about a function. Somehow we're going to bring different pieces together to create, bless you, or find something new. Okay? So our first example here is going to be a table. If you flip the page, you're going to see how we have some graphs to analyze. And then on the next page, notice how we have some equations. So depending on what we know, we're going to bring what we know together to create something new. Okay, what does f of x mean again? If I say f of x, it means the same thing as, yeah, y. So whenever you're given a table of values, especially when you have different functions listed, like f of x, g of x, h of x, these rows are just representing the y values from those different functions. Thank you, Rachel. Okay, so for instance, if you were to plug in the x value of -3 into the f graph, you would get 0. If you were to plug in -3 into the g graph, you would get -2. And if you were to plug in -3 into the h graph, you get 1/2. I think we're pretty used to reading a table of values. Is that assumption correct? Okay, so let's go ahead with this table of values. We're going to compose different functions together, either adding them, subtracting them, multiplying. We'll get to take a look at letter E here. That's a different way of composing. Anything for the office today? I think we're good.
Good morning.
Good morning.
Good for office.
I think we're good today. All right, thank you. Uh-huh. All right, so let's look at our first composition. We're going to bring together a value from the h function and a value from the g function. Can we identify what h of 0 would be based off the table? Can we read it? Yeah. Positive 2. Okay, x value of 0 plugged into the h function would give us a positive 2. So we're going to replace or substitute that value. Next, we got to multiply. If we were to plug in -3 into the g function, can we find that based off the table? Good, Maddie? We got a -2. Good. Okay, so I want to see each step of your work here. I know some of you might be able to do these in your head, but if you for some reason get something wrong or mess something up somewhere, I want to see where that is. Okay, because maybe I can help you correct a mistake so you don't keep making it over and over again. So I know you might be able to do this in your head, but I want to see the work. Where are the numbers coming from? So we have -3 times 2 times -2. Looks like we'll be left with 12. Okay. So there's our first composition. We brought two different values together from the H graph and G graph, and we merged them to find this new value. Okay, we're bringing in different values from different graphs. Do you guys think you can try B? Can you do the next composition? Show the work, where are the numbers coming from? While you're at it, maybe go ahead and try C. Any takers on B? Can you show me where you got the numbers? Good, Maddie?
Can you leave it in top of fraction?
Sure. Mm-hmm.
So it would be 2
Uh-huh.
times 7
Yep.
and then over 3.
All right, so what was your improper fraction?
14 over
14 over 3. You can leave it like that. If some of you want to change it to a mixed number, you could do that as well. If you want to convert it to a decimal, that's okay too. Okay? They essentially all mean the same thing, so as long as you can get it in the end, that's what I'm concerned with. How do we do on B? Pretty good? All right, any takers for C? What are your numbers? Yeah.
-1.
Okay.
3 times 7.
3 times 7, so what's your composition value for this one?
Positive 20.
Positive 20. How do we do on C? Pretty good? All right. We're going to get into some good ones here. We've briefly kind of talked about the way this notation looks for part D. Do we remember what that's telling us or asking us to find? Go to Rebecca.
H of 2
Uh-huh.
times F of 2.
Times F of 2. All right. So you're going to multiply the H and F function together specifically at the X value of 2. So we're going to plug in 2 into both of those functions. Based off the table, H of 2 would be 3. I'm sorry, 0. And F of 2 would be 3. 0 times 3 is 0. We remember that notation? Kind of tricky. It's a little different. All right. What about E? I don't think we've seen this one before, at least in this class. What do you think that's asking us to do or find? Yeah.
H of F of 2, so you find F of 2 and whatever number that is, you find it for H of F.
Perfect. Okay, so do you guys notice, like, just the way it looks, just the way it's written, doesn't it look like F of 2 is inside the H value or the H function? Okay, so whatever F of 2 is, we're going to have to plug that into the H function. Okay, this is a different way of composing things together. Once we find a value, we're going to plug that value in. So let's go ahead and find F of 2 first. Based off the table, that would be 3. And now we're going to take that 3 that we found and plug it into the H function, which based off the table would be -1. Okay, a little different. So you're taking one value you find and plug it into the next function. We're going to get really good with these. Take a look at J, K, and L. We're going to get a little crazy where we have 3 functions to plug some values into. Do you guys think you can try F through L? Notice how they're all kind of the same format? Go ahead and see how you do. Yeah.
For ones like C, whenever we do it, is it okay if I like did like, or not C, E, sorry.
Mm-hmm.
If I did like H and then parentheses, then parentheses, and then everything.
Like you only showed this?
Yes.
That's fine.
Okay.
Yeah. All right, any takers on F? If you plugged -3 into the F function, what would you get out? Good, Brianna?
0.
0? Okay, so then if you take that 0 and plug it into the G function, what would you get? -2, I like it. How do we do on F? Good? All right, let's keep going. G, if you plugged in -2 into the G function, what'd you get? Good, Marie? 1, and if you take that 1 and plug it into the H function? -3. Check plus on G. Yep. All right, what about H? If you plugged 3 into F? Yeah.
2.
2, okay, and if you take that 2 and plug it into G?
0.
You got 0. Let's go ahead and check that out. So F of 3 is 2. And if you take that 2 and plug it into G, I think you may have looked at H.
I think it threw me off because the problem was letter H.
Oh, letter H. Oh, I can see that. Okay, definitely. Is 5 a little bit better? Okay. What about I? If you take 1 and plug it into H. Good, Emily? -3. And if you take that -3 and plug it into F,
0.
you got 0. I check out. All right. Triple ones. Who wants to try J? Good, Maddie.
F of 2 gives you 3.
Okay.
G of 3 gives you -3, and then H of -3.
Very nice. How do we do on J? All right. Takers for K. Good, Marie.
F of -1 gives you 2.
Okay.
H of 2 gives you 0, and G of 0 gives you -1. -2.
-2. How do we do it for k? We're just rolling through. All right, last one, L. Go, Rebecca.
G of -3 equals -2.
Okay.
Then f of -2 equals 3. And then g of 3 equals -3.
How do we do for L? Pretty good all the way through? We're master composers. Really good. Okay, let's go ahead and step it up a bit. We're going to take a look at M. So we're going to use some of these compositions that we're able to find to help us perhaps solve some equations. Letter M is telling us if the k equation is 2x plus 10, then what are the values for x? Maybe there's more than one. So that the k equation equals this composition. Okay, so we're going to have to figure out what that composition is based off the table. Do you think we can go ahead and do that? If we were to plug -1 into H, and then take that value, plug it into G, and then take that value and plug it into F. Another triple one. Yeah.
You get 1 for H.
For H, okay, so take that 1 and plug it into G, and we get 0, and take that 0, plug it into F,
-4.
we get -4. All right, so the composition value is -4. So let's take a look at this statement that we're trying to figure out here. The k equation equals the composition. Do we know what the k equation is? Didn't they give that to us? 2x plus 10. And that should equal the composition value, which we just found was -4. Can we solve for x? Figure out the value or values? Let's go ahead and subtract the 10 over and divide the 2. We kind of remember doing those a few sections ago. Okay, this time we're just stepping it up a bit because maybe we're throwing in a composition value that we need to find. Okay, but very similar questions to what we've seen. Let's go ahead and try n. This time the p equation is an absolute value, and we're going to try to find those x values so that the p equation equals that composition. So let's go ahead and find that composition first. Go ahead and use the table. If you were to plug in -2 into the g function, good, Marie? You get 1, and if you take that 1 and plug it into the f function, good, Marie? You get 4. All right, so there's our composition value. We need to set the p equation, which was the absolute value, equal to that composition. And we got to solve for x. What are we going to do with this absolute value? Go, Rebecca.
Set it equal to positive and the 4.
There we go. We have two options. So we have possibly two answers here. Let's go ahead and do each one individually. Let's see, the first one, if we add over the 3, we'll get 7, and then divide the 2. So we got 7 halves. And the second one, if we add the 3, we'll get -1, and then divide the 2, we'll get -1/2. We hanging in there? Am I going too fast? Too slow? Just right? Goldilocks? All right, so we can find composition functions or values based off of a table. I think that went pretty well. Let's go ahead and try to do something very similar, but this time, what if we were given a graph? Okay, a different piece of information, or at least a different representation. Okay, so same idea. We're going to be composing function values together, either adding, subtracting, multiplying, dividing. Maybe we're putting one value inside of another one, kind of like those double or triple ones that we saw. Let's go ahead and check out A. If you were to plug in 2 into the F graph that we're given, what would you get out? Can we find that Y value? Good, Marie? Right, if you plug in the x value of 2, you'll get out the y value of 2. And if you were to plug negative 3 into the g graph, looks like you would get negative 2. All right, so we have negative 6 minus 2. Looks like our composition value is negative 8. Do you guys think you can try B and C? Use the graphs to help you out, find those values. Any takers for B? Yeah. You- you- You want to do it? Go ahead.
G of 3 is 1.
Okay.
F of negative 1 is positive 3. Or it's negative 3.
Negative 3, right?
Negative 4.
You get 4. Okay, so it would change to a positive 3. Good.
Yeah, I like my process.
That's okay. Yep. How do we do on B? Check it out. Okay. Takers for C. This time we're composing by multiplying things together. Go ahead, Marie.
G is negative 2, 0 times F of 3 and F of 3 is 3, 0.
You get 0. How do we do for C? Pretty good? All right, let's go ahead and try to practice kind of the new one for us where we find one value and plug that into the next function. So we're going to first find f of negative 1, and whatever that is, we're going to plug that into the g graph. Let's see, f of negative 1 based off the graph is negative 3. And if you were to then take that negative 3 and plug it into the g graph, looks like you would get negative 2. Do you guys think you can try the rest of them? Got the hang of it? Okay, try E through L. Any takers on E? Plug in 0 into the G graph, what'd you get? Go ahead. Hannah, I'm coming to you next, okay? Go ahead. Bree. You got 2, okay? And if you take that 2 and plug it into the F graph, you get 2 again. How do we do on E? Good. Hannah, do you want to do F? Is that okay?
Sure.
Go ahead.
-2 is -1.
Okay.
And then G -1 is 3.
Is 3. Very nice. How'd F go? All right. Any takers for G? See, go ahead, Hannah.
F of 0 equals -2.
Okay.
And then G -2 equals 0.
0. G check out for us. Okay. What about H? Yeah.
-2 is -2.
Okay.
F of -2 is -1.
-1 looks good. Doing okay on H? All right. I. Good, Brianna?
G of -1 is 3 and F of 3 is 3.
How do we do on I? This train is rolling. All right, J. Yeah.
F of 3 is 3.
Okay.
Then G of 3 is
1. Perfect. Hanging in there. So far, so good. Okay. What about a triple one? Any takers for K? Go, Marie.
F of 1 is 0,
Okay.
G of 0 is 2,
All right.
2 is 2.
F of 2 is 2. How do we do on K? Perfect. All right, and then the last one. Go ahead, Maddie.
F of -3 is 1.
Okay.
G of 1 is -1. G of -1 is 3.
Is 3. How do we do? Across the board, awesome? Really good. All right, so let's go ahead and step it up. Use maybe some of these compositions to help us solve equations. Part M, they give us the H equation, and they're asking us to figure out when is the H equation equal to this composition. So let's go ahead and figure out what that composition might be. If you were to plug in 1 into the F graph, what would you get? Yeah, 0. So then if you were to take the 0 and plug it into the G graph, you would get, good, Marie? 2. All right, so let's go ahead and set up our equation. We need the H equation, which they gave us, and we're going to set that equal to the composition, which we found was 2. So now it's our goal to figure out what are the value or values for x that would make this true. What do you guys feel like doing? Anything popping out at you, giving you a clue? Yeah.
Set it to 0.
Why do you want to set it equal to 0? That's awesome.
Because it'll form like that.
You can make it a quadratic equation, and how could you solve it? What could you do? You have some options. It's it. You could factor, or you could use the quadratic formula. Okay, factoring is a little bit easier. Quadratic formula is a little bit more involved, but let's go ahead and try to factor. So think about your factoring techniques: GCF, IAM, difference of squares, maybe the either grouping or divide and slide method. Think about which one's going to work here. Okay, can we find those two factors? Yeah. -2 and +1. All right, this fits the IAM profile because your coefficient in front of the x squared is 1. So two numbers that multiply to -2, add to -1. Ashlyn found -2 and +1. Perfect. So what are your solutions for x based off those factors? Yeah. 2 and -1. Perfect. All right, let's try n. The p equation is an absolute value, and we're going to figure out when does that p equation equal the composition. So let's figure out what that composition value is. If you were to plug -2 into the G graph, go Marie, we got 0. And if you were to plug 0 into the F graph, okay, we got -2. All right, so the P equation, 3 times the absolute value, and that should equal -2. What do you want to do to help figure out what X is? Yeah?
Would you want to divide by 3 to get the absolute value?
Let's go ahead and move the 3 over. So now that the absolute value is all by itself, what do you want to try? Yeah? You would think, right? That's how we normally solve it. Something's different about this one, yeah.
Is there no solution?
Why?
Because there's a negative with the absolute value cannot be negative.
Okay, so this is when you got to be really careful, okay? You're going to get into the habit of every time you have an absolute value, breaking it up, okay? I already see that happening, which isn't a bad thing, okay, because typically they're going to work out. But if you really pay attention to what this is telling you, it's telling you that no matter what X value you plug in here, okay, and you were to take the absolute value of it, your answer would be a -2/3. Can an absolute value ever be a negative number? No, okay? So with the way this is set up, we'll say there is no solution because an absolute value is never negative, aka never equals a negative number. Okay, again, you're going to get into that habit because yes, usually that's how it works, but you got to pay attention to what you're working with. We hanging in there? All right, I think the table went well. We just did really well on the graphs, right? Okay, let's go ahead and take a look at maybe what if we have some equations. Okay, a different format of information. All right, so let's take a look at the top. We have 4 equations this time. Looks like we have a quadratic, 2 linears, and then do we remember what a fraction equation is called? We've seen that in a while, yeah. Rational, good. Okay, so we have 4 different equations. Let's go ahead and make sure we use the correct one when it's appropriate. So our first composition, we got to take the X value of 4 and plug it into the H equation, not table or graph because we don't have that representation anymore. So if we were to take 4 and plug it into the H equation, okay, that's our second linear one at the top. Let's see, 3 times 4 is 12, divided by 2 would give us a 6, and 6 minus 2 gives us 4. So now we've got to take that value of 4 and plug it into the G equation. Based at the top, that's our other linear equation. So it looks like we're left with 1 minus 8, which is -7. Okay, it's going to be a lot of bouncing around, kind of like the table in the graphs. You have to make sure you're using the correct function for the correct value. Do you guys think you can try 2 and 3? Yeah.
I always thought that you would set it equal to because it would be wrong.
We would set what equal to what?
For example, at H of 4, would be 4 equals 3 over 2x minus 2.
Yes, okay, so you could set it equal to it, but this 4 is representing an X value that you can plug in for X.
Oh,
Okay, so instead of writing X there, I just plugged in the 4. Okay? All right, so if you take a look at 2, we got to find the f of negative 2 value and then add that to the p of 2 value. So what you could do is figure out each one separately and then simply add those values together. Okay, that's how I tackled it. So if you plug in negative 2 into the f equation, okay, which is your first one at the top, plugging in negative 2 for all the x's, you should get negative 15. Are we okay with that value? There's a lot of negatives going on. Okay, p of 2, on the other hand, is your last equation at the top. Plugging in 2 for both x's, we can get negative 4. Are we okay with that value? Okay, so what this composition is telling us to do is to add those two together. Negative 15 plus a negative 4 looks like we would get negative 19. How do we do on number 2? Pretty good? Yes?
Negative 7 for the first part of it.
For the first one? Okay,
So,
go ahead.
I messed up like the first step.
Right here.
I made the 2 a positive because it already had a negative up there.
Okay, so if you think about your order of operations, okay, parentheses come first, so we got to focus on the negative 2, and then comes exponents, right? Please excuse my dear Aunt Sally. So we need to take negative 2 inside those parentheses and square that first. So negative 2 times negative 2 would be positive 4. And then you deal with the multiplication of negative 1, which would make the positive 4 negative 4. Okay? Lots of negatives, so I can definitely understand that computation. Okay? What about 3 on the other hand? We have that weird one where we got to take one value and plug it into the other one. So if you find g of negative 1, hopefully we can get 3. Are we okay with that? So we're going to take that value of 3 and plug it into the rational equation on top and bottom. Looks like we'll get 5 over 0. Yeah.
It would be undefined.
It would be undefined. Perfect. How do we do on 3? Pretty good? We feeling okay so far? Understanding? Compositions? We can add function values, subtract them, multiply them, divide them, even do the little weird ones where you take one value, plug it into the next one. All right. We're going to stop there for today. I want to save the chart at the bottom and then the page on the back for tomorrow, just as some refreshers and more practice. Okay? And then, I mean, it's not going to take all day tomorrow, so maybe we can either start the next section or try some homework problems. Okay? We'll see what kind of mood we're in tomorrow.